Good day everybody. We got an interesting question. We are expected to integrate integral e raised to the power of root of x times dx. Now such questions keep occurring in interviews as also in competitive exams and scholarships exams. So it becomes imperative to know how to operate on integrals of this nature, because we know that if we were to ask to obtain the integration of e raised to the power of x times dx, we would say e raised to the power of x positive c. But we are not exposed to situations where you got a square root there, right? So that would be a challenge. Now what I wish to do is I would like to do some slight alteration. So let me start off by stating, consider integral e raised to the power of root of x times dx. I'm going to write this as e raised to the power of root of x. I wish to multiply the numerator by 2 times root of x and divide it by 2 times root of x. Of course, I got the dx there. Now, this is rewritten as 1 over 2 integral e raised to the power of root of x divided by root of x times. Now, we got this root of x, right? Now to this root of x, I would like to add a negative 2 and a positive 2 with the dx being present there. So these are the following sets of changes that are made to the original integral. Of course, if you were to see this, the original integral is not altered at all in any ways. So from here onwards, let us proceed. Now I would like to rewrite this as 1 over 2 integral. Let me distribute this quantity inside. So I'm going to keep root of x as it is, and I will distribute e raised to the power of root x inside. So that would mean I have e raised to the power of root of x times. Now this is actually 2 here, right? So I need to place the 2 there. So e raised to the power of root x times 2 times root of x negative 2. This is one quantity followed by a positive sign. Again, I wish to distribute e raised to the power of root of x inside. Of course, the denominator follows along with that. So this is going to be e raised to the power of root of x times 2 divided by root of x. Now there is this dx being present there. So if I were to take e raised to the power of root x divided by root of x out, I would be getting 2 times root of x, negative 2, positive 2. So there isn't any change at all. The only thing is that I need to place a huge parenthesis to indicate that 1 over 2 is actually getting distributed all across. So now what I wish to do is I would like to consider two quantities separately. So this is equal to 1 over 2 integral e raised to the power of root of x. Now there is a 2 there, right? So okay, let me write the step. 2 times root of x negative 2 times dx over root of x. This is one quantity followed by positive 1 over 2 integral 2 times e raised to the power of root of x divided by root of x times dx. So let me consider this quantity. Consider 1 over 2 times integral e raised to the power of root of x. Now 2 times root of x negative 2. I can take that 2 out. So let me place the 2 there times root of x negative 1 times dx divided by root of x. Clearly 2 gets cancelled. So this is going to give me integral e raised to the power of root of x times root of x negative 1 times dx divided by, of course I got that root of x there. Now I would like to make the following substitution. Let root of x negative 1 be equal to t. So from here root of x is equal to t plus 1. If I were to differentiate this is nothing but x raised to the power of 1 over 2 is equal to t plus 1. I am differentiating this. So this is going to give me 1 over 2 times x raised to the power of 1 over 2 negative 1 times dx is equal to dt. This is rewritten as 1 over 2 times x raised to the power of 1 over 2 negative 1 is negative 1 over 2 times dx is equal to dt. This can be rewritten as dx over x raised to the power of negative 1 over 2 can be pushed down. So this is going to be root of x with a 2 there is equal to dt. Now clearly you can see dx over root of x is there, but we do not have the 2 there. because we have just cancelled the 2 over here. If you would not have cancelled it, we could have just retained it as it is, but we have cancelled it, but it's okay. So this can be further rewritten as dx over root of x is equal to 2 times dt. So in place of this, I can substitute 2 times dt. So let's do that. E raised to the power of root x. In place of root of x, I'm going to substitute t positive 1. In place of root of x negative 1, I'm going to substitute t. And in place of dx over root of x, I'm going to substitute 2 times. So the 2 is here and the dt is here. Now this is equal to 2 times integral t. Now a raised to the power of m positive n is a raised to the power of m times a raised to the power of n, right? This is by exponential rule. So this can be rewritten as t times e raised to the power of t times e times dt. This is equal to 2 times, e is a constant, so take it out. So all that you got is t times e raised to the power of t times dt. Now I can use integration by parts. So I take u is equal to t and dv is equal to e raised to the power of t dt. This is du is equal to dt. If I were to integrate this, this is going to give me v is equal to e raised to the power of t. So by formula, okay, let me just place that. By formula, let me write the formula. uv negative integral v du. I am using this formula. If I were to use this formula over here, this is going to be u is t, my v is e raised to the power of t, negative, my v is e raised to the power of t, times my du is dt, right? Multiplied with, of course I've got the constant 2 times e, so let me place the constant 2 times e. So 2 times e is there. So this is equal to 2 times e of t times e raised to the power of t, negative, I integrate e power t, I get e power t. Now e power t is common, so I can take it out. So 2 times e power t is taken out, giving me t negative 1. Now my t, clearly you can see t is root of x negative 1. Now this is nothing but 2 times e raised to the power of t positive 1 times t negative 1. This is equal to 2 times e. As I mentioned to you, t positive 1 is root x, so substitute that. And my t is root of x negative 1, so root of x negative 1, already there's a negative 1 there, substitute that. So this is equal to 2 times e raised to the power of root of x times root of x negative 2. So this is what I've got. Now this is one side, right? There is also another quantity. So let us consider this part. Okay, consider 1 over 2 times integral 2 times e raised to the power of x over root of x times dx. Now let me take root of x to be equal to t. Then if I were to differentiate this, this is going to give me 1 over 2 x raised to the power of negative 1 over 2 times dx is equal to dt. This can be further rewritten as dx over 2 times root of x is equal to dt, right? So take this, in place of this substitute this. So already you got this. So this is equal to 1 over 2 times integral. As I mentioned to you, I'm not going to touch this 2. In fact, I can use this 2 inside. So let me take that 2 out. So if I were to use this 2 inside, this is going to give me a dt. And 2 times e raised to the power of root of x is t. So this is going to be 2 times, when you integrate this, you get e power t, which is nothing but 2 times, my t is root of x. So substitute root of x. So now what we need to do is we need to add this quantity with this quantity. So if I were to take this as sum a, take this as b, I have to add a with b, right? Therefore a with b. So this is equal to 2 times e raised to the power of root of x times root of x negative 2 positive 2 times e raised to the power of root of x. Now 2 times e raised to the power of root x and 2 times e raised to the power of root x can be taken out. So 2 times e raised to the power of root of x. So this is going to give me root of x negative 2, and I have a positive 1 here. So let me write the final solution. This is what we've got: 2 times e raised to the power of root x times root of x negative 2 positive 1. Now clearly you can see that negative 2 and positive 1 can be added. So this is going to be 2 times e raised to the power of root of x times root of x. Negative 2 added with positive 1 will give me negative 1. Now this is the solution, but since we are dealing with indefinite integrals, we will have to add the arbitrary constant c. If you don't add this arbitrary constant c and then place this alone as the solution, then it's incorrect. So you got to place this arbitrary constant c. So that is the solution for this quantity, integral e raised to the power root of x times dx, which has given us 2 times e raised to the power root of x times root of x negative 1 positive arbitrary constant c. Thank you everybody, enjoy your night.